So shifts aren't the only transformations that our functions can have. They can also be stretched, compressed, and reflected. So if you see a number being multiplied in front of the function, so all of our transformations so far with the shifting have been adding and subtracting. So if you multiply the function by something, then this is going to be a vertical stretch or vertical compression. And it depends on what the number is. So if the number is, or the absolute value of the number is greater than 1, then it's going to stretch it. If the absolute value is between 0 and 1, then it's going to compress it. And between 0 and 1, that's kind of another way of saying that this is a decimal or a fraction that's less than 1. And again, absolute value means we ignore the negative sign. Although the negative sign is important for the next thing, which is reflection. So if you see a negative sign out in front of the function, it's going to reflect across the x-axis. If you see a negative sign on the inside of the function, it's going to reflect across the y-axis. So let's look at number 9. It says, how is the graph of 3x squared transformed from x squared? Well, we know that this is just going to be a vertical stretch of factor 3 because of this 3. So if you were to graph it on your calculator, you'll see that we have our parabola, and then the new one is going to look like this. And it's really called a vertical stretch because for every value you would go up, the y value is increasing upward. 1/3 x squared, if I transform that from x squared, that is a vertical compression of factor 1/3. So if you were to graph that on the calculator, or both of those on the calculator, you would see the parabola, and then your new one would look something like this. And that one's called a compression because all of your y values are below the original y values. So that would be our answer. Number 11, we have negative square root of x. So because the negative is on the outside, that means that this is reflected across the x-axis. So your graph, if your graph looked like that for your original, and you graph the other one, it would look like that. So it's just taking a copy and reflecting it. And in a similar way, if you see a negative on the inside, that's going to reflect across the y-axis. So my graph, or original graph, looks like that, and when I reflect it, it's going to look like that. So you don't have to graph it for these, but it's kind of nice to just confirm that that's what's going on when we're first starting out to look at these reflections and compressions. Let's do 13 and 14. So there's actually two things going on with this one because we have the negative sign on the outside and you have the 4. So that's two different things. So the 4, that would be a vertical stretch of factor 4. And then the negative sign, that's going to reflect it across the x-axis. So it's really two different things going on there. And with the next one, we still have that negative sign, and then we have a 0.2. So that's going to be, because it's 0.2 and that's a decimal between 0 and 1, it's going to be a vertical compression factor 0.2, and it's going to be reflected across the x-axis. So again, to be reflected across the y-axis, you would need to have a negative sign on the inside of the function, or it would have to be on the inside of a parentheses. So that'll be our answers for these ones.